The aviation industry is responsible for 2.1% of global CO2 emissions. This is 12% of the emissions from all transport sources. So, reducing aviation emissions is an important contribution towards tackling climate change. The UK has committed to achieving net zero greenhouse gas emissions by 2050. One of the key ways to do this is to use alternative fuels. The most important low-carbon fuels for aviation are biojet fuels, hydrogen, and power-to-liquid technologies. However, we need to be sure that these fuels are really better for the environment and don't simply replace one issue with another. We need to evaluate their total environmental impact, not just how burning the fuels would reduce greenhouse gas emissions, but also the effects of producing the fuels. This will take energy, raw materials, water and land away from how they are currently used. What effects would this have on the environment? For these alternative fuels, it's also important to assess all types of emissions, not just CO2. Aviation emissions can include nitrogen oxides, water vapour, particulates, carbon monoxide, unburned hydrocarbons, and sulfur oxides. These have a 2 to 3 times greater impact on the climate than CO2. Researchers at Imperial College London have evaluated low-carbon aviation fuels to provide a reality check for the technologies proposed to achieve net zero. In order to do this, they used 3 key parameters. These are total greenhouse gas emissions, the resources needed to produce the fuel, and the scalability of the technology to meet UK aviation fuel demand. For each solution, they investigated how should the total greenhouse gas emissions impact of each fuel be calculated? How would the demand for feedstocks, energy inputs and land for these technologies compete with existing demands? How ready are these technologies to deploy at scale? And finally, what policy tools could encourage the development and adoption of low-carbon fuels? And what are their pitfalls? Read the briefing paper by the Institute for Molecular Science and Engineering to learn about the emissions impacts of low-carbon fuels and find out how policy should support their development and adoption.